Okay, yes, we're going. Usually it gives me a little countdown, and there was no countdown. So I guess we're going. So good morning, or afternoon, or good evening, or good whenever you are watching this video. So if you have not already done the Spark for 15.1, then you'll want to go ahead and do that. Otherwise, let's jump in and see how I thought about this problem here. So a florist needs to make 10 bouquets. So I know I need 10 of 40 carnations, 36 red roses, 24 yellow roses, and 24 lilies. How many flowers should there be in each bouquet so that each bouquet has the same number of flowers? So one thing I think is important here is to notice that it just says that it has to have the same number of flowers. I don't necessarily need the same number of carnations, the same number of red roses, yellow roses, lilies in every bouquet. So every bouquet doesn't have to look the same. It just has to have the same number. So if the first bouquet has 7 flowers, the second bouquet has 7 flowers. So I know I need 10. So I'm going to start and see how many flowers do I have all together. So I have 40, 36, 24, and 24. So here's 10 plus 4 is 14. And here's 5, 6, 7, 8, 9, 10, 11, 12. So altogether, I have 124 flowers. So I know I need to cut those into 10 equal groups. So I can see that 10 goes into 12 one time, 2 left over, bring down my 4, 10 goes into 24 two times. So I think that, and then I've got a remainder here of 4. I've got 4 flowers left over. So my answer is that every flower bouquet should have 12 flowers. And then I'm going to just have 4 flowers left over that are just going to be extra. I don't have enough to give another one to everyone, and they have to have the same. So if I only gave out those 4 flowers, I'd have 4 bouquets that had more and 6 of them that had fewer. So I'm thinking 12 flowers, remainder 4. So let's take a look at some of the answers that it gave us in our Spark. So what is true? So we know, right, our total was 124. We know that every one bouquet would have 12 flowers, and there will be 4 flowers left over. So go ahead and find the answers that match up to our proof right here. Then when you are done with that, let's jump to task 1. Or I can for today. So we are working on finding the fair share or the balancing point of a data set. So we're going to be using our number lines and finding these fair shares. So in that last problem, the fair share of flowers was every bouquet had 12 flowers. So it can be called the fair share, the balance point. You might hear it called the average or the mean. All of those are meaning the same thing. So if you can find the fair share and the balance point and use a number line to prove that, then you are at a 3 today. If you can do that and explain it to somebody else, that's a 4. If you can find the balance point of a set of numbers on a number line, that's a 2. And if you can just find the fair share of a group using a model and drawing it out, then that's a 1. So just drawing it is a 1. Number line is a 2. If you can do both ways, that's a 3, a model or a number line. So I guess I should say and a number line. So do both of them. And if you could help teach that to somebody else, then that bumps you up to the level 4 today. Okay, so let's look at number 1, task 1. If everyone has a fair share, so just let's think about those words. Fair kind of means that everybody's getting the same and we're sharing them. So everybody gets the same shares or the same parts. They all have the same number. So let's look at our picture here. So look at the model. So for each friend to have the same number of shells or a fair share of shells, what needs to happen? So friend 1 collected 6 shells. Friend 2 only found 1, and friend 3 found 5 shells. So they all want to share them, right? Maybe they're working together as a team. Said, right, we'll all collect them and then we'll break them up so everybody gets the same amount. So what do we need to do here to make it so that everybody gets the same amount here? So, right, we can see we definitely need to be giving some to this person here. So I'm going to take this one and I'm going to move it here. Okay, so now this one has 5, this has 2, this one has 5. So we have 2 of them that have a fair share, but still missing 1 here. So I'm going to take 1 more and give it to this person. So now this person has 4. This has 1, 2, 3. And this person still has 5. So now what do we need to do? Looks like this person has too many. So let's take one of theirs, give it to the person with the least. So now this person has 4. So 1, 2, 3, 4. This person has 1, 2, 3, 4. And this person has 1, 2, 3, 4. So the person that had 6 needs to give 2 to the person with 1. And the person with 1 needs to give 1 to the person that only had 1. Now they all have 4, 4, and 4 seashells. So another way I can think about that is I can see how many total shells did we have. So here's 6 plus 1 is 7, plus 5 more was 12. They had a total of 12 shells. How many friends wanted to share them? 3 friends. So 12 divided by 3, they each got a fair share of 4 shells. So if you can use this model, right, and drag and drop and recreate and just move them around till everybody has the same, then that is your level 1 today. So now let's think about if 3 friends found 9, 1, and 5 shells, how many would each person get? So, right, this person has a lot, so we've got to give some over there and kind of see what happens. So I'm going to start and see how many shells do they have all together. So 9 plus 1 is 10, plus 5 more is 15 total shells. And it tells me they want to share them with 3 friends. When we're sharing things, that means we're dividing. So 3 goes into 15 5 times. So if I have 9 shells here, or I don't think I have a shell, but we're going to do flowers. So they could kind of be like sand dollars. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This person has 1, and this person has 5. So I'm going to, right, take this one, bring it over here. So they're not equal yet. And I always want to take from the one that has the most and give it to the least. So, those 2 are connected together. Let me try taking that one. So this one still has more. So I'm going to take this guy. So we've got 6, 4, and 5 getting closer. Oh, apparently all of these are connected together. So let's just take one away and put one back over there. So now I can see this has 5, 5, and 5. So just taking from the biggest one, giving to the one with the least amount until they are balanced out. And just like that flower problem we did it for the spark, sometimes you can have extras that, I don't know, maybe are just left out. Maybe you're going to rock, paper, scissors for them, or however your group chooses to share those. So go ahead and complete task 1 about fair shares, and then come back when you are ready to do task 2. So task 2 is about the balance point, which is very similar to our fair share. But instead of moving pictures and items around, we're going to balance out a dot plot here. So first of all, which dot plot represents the 3 friends that found 6, 1, and 5 seashells. So look for the number that has 6, 5, and 1. They might be in a different order than yours on your computer. Sometimes they randomize them there. So I'm looking for 6, 1, and 5. So I've got 1, 6, 7. It's not that one. 1, 4, 6. No, 1, 5, 6. So this one here is my dot plot. And we're going to be continuing to use this dot plot as to answer some other questions. I'm just going to make it a little bit bigger here so we can work with it easier. So here's our dot plot. Which number represents the fair share that each of them got? So looking back, right, we gave 2 here and 1 from here until they all had 4. 12 total shells divided by 3 friends is 4. So our fair share number is 4. So I'm going to mark that with a red X here. Here is my fair share number. We want everybody to have 4. What is the distance from each data point to the fair share number? So, right, I've got this number 4 is my fair share. So this person had a 1. So to get from 1 to 4, they have a distance of 3. Then this person had a 5. So to get from here to here, that was a distance of 1. So you can either, subtract those numbers or count over 1, 2, 3. To get from 5 to 4 is just a distance of 1. And then we also have this 6, which is a distance of 2 away. 1, 2. So we can see here's all of the distances to get to that fair share number of 4. 3 away, 1 away, 2 away. So what do you notice about the total distances from the data points on either side? So either side, so let's kind of split it down the middle here. So what's the total distance on this side is 3. The total distance on this side of the fair share number, so total is 1 plus 2 equals 3. So what do you notice about the distance between the numbers on each side and the fair share? They're exactly the same. To get from here to here was 3. To get from all of these numbers to the fair share number was also 3, right? It's a fair share. It's balancing that point right in the center. So, right, we can kind of think of this as like a balance. So here is that centerpiece, and it's kind of resting this tray on here. So these ones, right, are a little heavier. They're 5 and 6, but they're much closer to this little point here. Where this one is farther away, so it kind of balances it out here. So, right, but they each have a distance of, here's 1, 2, 3, 1, 2, 3. So their distances are the same to get to the point. No matter how many are on either side of that point, we want the same distances, gives us that balance point or our fair share number. So a balance point of a data set is the point on a number line where the data distribution is balanced, right? This was balanced 3 away. These were balanced 1 plus 2 is a total of 3. So to get to the fair share number, we need our sitting in the dark. So to get to our fair share number, everything is balanced on both sides. So what number from the dot plot in part A represents the balance point? So, right, our balance point is 4. Our fair share number and our balance point is 4. So let's try one more of those. So we had this other one that we did here. And actually, I'm going to hurry and quick search up a number line so we can practice this other one here. So let's get a number line. I don't want a blank one. Let's try 10 to negative 10. Here we go. So even though we don't have negative shells, that's probably my quickest one to grab. Let me get rid of a few of these things here. And okay, so we had one person found 9 shells. So I'm going to put a dot above 9. One person found 1 shell, not -1, 1 shell, and one person found 5 here. So we decided our balance point, right? It was a total of 15 shells. 3 people are sharing them. Our balance point was also 5. So our balance point was 5 here. So one of these people, right, didn't have to give up any shells. Or get new shells. They just kept the ones they had. So I can see to get from my balance point or my fair share number to the points on this side is 1, 2, 3, a distance of 4. This one also has 1, 2, 3, 4. So they both have a distance of 4. So we gave 4 of these ones to here and we were done. So with that distance, right, we had to give 1 of these shells over here and 2 of these shells over here, which is exactly what we did, right? 2 from the 6, 1 from the 5. Now they all have 4. So that balance point and the distances kind of all go together. So the fair share and the balance point are the same number. The distances just tell us how far to get to the balance point from each point, and it should be the same on both sides of your balance point. So go ahead and complete task 2 and then do your check for understanding and homework for today. If you have any other questions about the fair share or balance point, be sure to let me know and we can set up a time to meet together.